Hello, Adi.
Hello.
What we done?
And the angle 7.
The morning. Let's not waste any time. I think today many people they went to Saturday classes at school. So let's just start with our classes. I will record the lesson and send to them when they come back from school. So now I'll start by attending to the correction of the questions I gave you last time as homework. So on the first question, we were given a cycle. So wherein in this cycle, we have a chord. So a chord is a line that goes from the circumference to the circumference. And this line is not passing through at the center of the cycle. So if it was passing through the center of the cycle, what was going to be the name of that line? If it was passing through the center of the cycle and it goes from the circumference to the circumference, what was going to be the name of that straight line?
It's a diameter.
Yes, it was going to be diameter. Um, so on question number 2, we are given that AE is equal to 8, FE is equal to 4. So we are required to calculate the length of OF. Yes, it's question number 3, this one. So we are required to calculate the length of OE. This length here is the one we are calculating, the length OE. It's unknown. We want to calculate what will be the value of that. And we're given a hint that OF is equal to OA, which is equal to X units. So can you tell me why are they saying that OF is equal to OA? What is the reason behind this? Why are they saying OA is equal to OF?
Radii.
These are the radius. So this is a radius and that is a radius. So that's why they say this side here is equal to that side. And that is the trick of attending to these questions. So once you understand that, I can tell you, you will be able to answer this question without any hesitation. And on this theorem, on this question, we're going to use the theorem I've done with you already, of which is about the midpoint theorem. So what does midpoint theorem? So midpoint theorem, it says that if OE is perpendicular to AB, then the distance from AE is the same as the distance from AB. That is what midpoint theorem says. So it's the one that we're going to use. But we are going to focus on this triangle here. So if we have a 90-degree there, it's when we can be able to also use what is called the Pythagoras theorem. So Pythagoras theorem, it works when we are having a right-angled triangle. And this is the right-angled triangle. How do we know that this is a right-angled triangle?
90-degree angle.
Because of this 90-degree that we have down there. So that information which I explained to you just now is going to assist us to answer the question at hand. So let's use Pythagoras theorem on this triangle. Can you tell me how can we reshape a Pythagoras theorem from this triangle here? We know Pythagoras is x squared plus y squared equal to r squared, but we want to write it in terms of what is given there. Can you give it to me when we are writing it according to what is given there?
OE squared
So
plus AE squared is equals to OA squared.
very true. So OE squared plus AE squared is equal to OA squared. The order, it doesn't matter here. So you can write whichever way you like, is the same. So then after having that, we are going to take advantage of this fact here that OA is equal to OF. So let's write OA in terms of OF. So O or AO should be equal to OF, which is OE plus. Let me write it there. So AO is equal to OE plus EF. So this side here, the side AO is the same as the side OE plus EF, because OE plus EF is the same as OF. Is that clear?
Yes.
All right. So now let's write AO with the information that is given there. Because here we are given that FE is equal to 4. Therefore, here where we have EF, we can substitute this value of 4. So we will be left with OE plus. Then here where we have EF, we substitute 4. So then now the next step here is just to substitute this information that is given here and that other information of AE, which is equal to 8. So we substitute these two information which I ticked there into the Pythagoras theorem. And once you substitute that into the Pythagoras theorem, you will be able to see what is happening here. So let's substitute this into the Pythagoras theorem. So it means where we have AO or OA, we're going to substitute this. Where we have AE, we're going to substitute 8. And with that, we'll be able to calculate distance OE. So let's do that and see what we get. So the OE is given. So we just write it as it is, plus. Now tell me, what are we going to substitute here where we have AE?
8.
We're going to substitute 8. Right. Equal to, what are we going to substitute where we have OA?
OE plus 4.
Definitely. So it's OE squared plus 4.
Hmm?
All right. Something here. So it's OE plus 4.
Sir,
Like this.
sir,
Yes.
I don't know OE equals to x minus 4.
Yeah, even that is fine because OE is the same as X, né? Is given. Yeah, if you replace AO by X, it's fine because that is the information that is given.
Okay.
Yes. So can we continue from here going down?
I'm not sharp.
All right. So now the next step is just to expand this here. We can, let me explain for him so that we can go together on this question. Question number 3. We haven't done question number 2 as yet. We're going to go back to question number 2. This is the first question. So on this question number 3, we are given that AE is equal to 8. From here to there, it's 8 units. And we're also given here to there, it's a 4 unit. So our question requires us to calculate OE. So I asked there before that in this case, we're given that OF is equal to OA. And I wanted to know from here, why do we say OF is equal to OA. Can you deliberate on that as well? Why are we allowed to say OF is equal to OA in this case? Why? What's the reason behind that? Tondani, why do you think we say OF is equal to OA? Why? What's the reason?
Radius.
That is the radius. It's as simple as that. So, and then from there, because we are given that this is a right angle triangle, we know it's a right angle triangle because of the 90-degree we have there. So if it is a right angle triangle, we are now allowed to use the what? The Pythagoras. So we can use the Pythagoras. So hence we need to write the Pythagoras for this triangle that we have here. And that is the Pythagoras of that triangle we have there. And then the next step is just to write OA in terms of this distance here, because on this line, we have this information that is given. So we can take advantage of that. So we can write OA in terms of OF, of which OF is OE plus EF. That is what we have done here. So AO, this side here is equal to OE plus EF, and you're going to have this equation there. But we know EF is given, therefore, where we have EF, we can substitute for, and we'll obtain this equation here. But from the previous information, we are given that AE is equal to 8 units. So where we have AE, we can replace by this 8 units that is given there. So is that clear?
Yes.
Yes. Then now the next step is just to substitute these two information back to the Pythagoras theorem. So that is what you're going to get there. So we are looking for OE, therefore we can't substitute anything there. AE is given, so you just substitute that value that is given, and then OA, you substitute this previous expression you're given there, you're going to get this. Therefore, it must not be outside, otherwise we're going to be in trouble if that is the case. So then now the next step is just to find the product on this. So finding the product you have done in grade 10, you must remember how to find the product, because that is what we're going to do exactly on what we have on the right hand side. So let's do that and see what we obtain by finding the product. So it means other things, we are just repeating them as they are. Or maybe if we like, we can write a to the power 2 as what? As 64, right? Now, can you find the product on the expression we have on the right-hand side? Can any one of you tell me what are we going to obtain when we find a product on what we have on the right-hand side?
I think we're gonna write OE plus 4 of x squared. OE.
It's OE squared, right?
Yes. And do 6
It's OE plus
8
plus 8 OE, right? And then plus what?
Yes. And then it's gonna be equals to,
And then plus what here? Plus
I
6.
think it's,
Is that clear?
yes.
So then now we group the terms. Everything that have OE, we take them to the other side. We can take them to the other side. And then these ones without OE, we take them to the left-hand side. Let's do that and see what we obtain. So it means we're going to have 64 minus 16, which is equal to OE squared. And then this one, we take it to the left-hand side, we're going to have minus OE squared, and then plus 8 OE. So that is what we're going to have there. Are we together up to that point?
Yes.
All right. I can see there's a light here. So let me just write below there. What is 64 minus 16?
48.
So we have 48 equal to OE squared minus OE squared is a 0, right?
Yes.
It means we left with 8 into OE. Do you all see that?
Yes, yeah.
In order to make OE the subject of the formula, what do we do?
We take OE to the other side, to the left hand side.
Which one do we take to the other side?
OE.
Yes, yes. It's possible that we can write as 8 into OE equal to 48. We are allowed to write that. So, and then the next step after
Okay.
doing that, what do we do from there?
We divide both sides by 8.
We divide both sides by 8. So that 8 here cancels with 8 there. So we're going to have OE, which is equal to, what is 48 divided by 8? You can use your calculator to tell me this answer.
6.
It's going to be 6. Adi, did you see how we got to that value of 6?
Yes.
All right. Now, if there is somewhere you did not understand me, it's now your time to ask me anything from what we have covered here. You can ask anything.
Sir,
Yes.
no, I don't want to try now.
Okay, let me check on the question you sent to me. How did you get to 10?
No, OE equals to x minus 4.
No.
X.
The problem is there on the x minus. It's supposed to be x plus. Okay. Let me check it again. Yeah, you can check the answers from your book.
Three equal to 10 units.
Question 3 equal to 10 units.
Hey, you know here right now.
All right. So let's verify where we are not arriving to the correct answer. Let me verify. All right. So we have this. So it's OE squared plus AE squared plus OA squared, of which OA is the same as OE plus EF. So is that OAO is equal to OE plus 4. And then after having that, we substitute this AE equal to 8. So it's this one. So then now this is the one we're looking for. Here we substitute 8, and then there we substitute this, because that is the same as this. We are still fine there. And then down here we have we have 8 squared, which is 64. So 8 squared is 64. And then here we have 8, and there we have 16. After having that, we take this to the left hand side and this to the right hand side. So we have 64 minus 16 equal to then this side, this minus that. So we have 8. And then we divide both sides, we get 6. 6 times 8 is it 64. It's 48. Yes. Let's interrogate your solution, because I don't see any step where we did wrong here. So let's find out from what you have done and what the book has done, so that we justify the solutions we obtained here.
Nando is a Pythagoras name. Now data OE equals to x minus 4. But then that x squared, the jelly x that x squared equals to 8 squared plus open brackets x minus 4 close bracket squared. That x squared equals to 64 plus data x minus 4 0 bracket equals to 64 plus x squared minus 8x minus x squared. Data 64 plus and data h squared lani data 64 plus h squared. Yeah, 64 plus 16. Yeah, that's done is Java 8. That divide and 8. Tambisera 10.
Okay. Let me see. Yeah, we're supposed to get to the same answer. But I'm trying to find out. Okay, let's check there where we have x minus 4 all squared, né?
Yes.
Yourself, we have x squared minus 8x minus x squared. Yeah, why x squared minus 8x minus x squared again?
Huh?
Okay, from that answer you provided, we have something like this.
Yeah.
Yeah, is it minus x squared or is plus 16?
It's plus 16 upon to talk and do the x. Upon Pisironia per x.
Yes, yeah, it must be plus 16, right?
Yes.
So then now let's see if it is plus 16. What are we gonna get? Oh, okay, now I see what's the problem. Now I see what's the problem. You obtained the value of x. So your question is not yet done. Ka question yasho almost ngo fikari wana value ya x. Obo fikari wana mini. Obo fikari wana OA. X ya base is this one, right?
Yeah.
So this question required us to obtain this distance here, not x. So in honor x in never 10, which is correct. But we are not looking for 10, but we are looking for what? For OE. Do you see that?
OE.
Yeah.
Yes.
So I think it's clear now.
Yeah, now it's clear.
All right. Are we together?
Yes.
All right. Let's go to the next question. So let me wrap this. The next question is question number 2. So I'll be wrapping that and then we focus on question number 2. So question number 2, we are given a similar cycle with a chord. So this is the chord AB. And then the center is there, goes to C, and then this is O, and then it joins B. And here we have 1, and there we have 2. Down here we have D. So this is the information we are given, where we are also told that OB is equal to 13 units and AB is equal to 24 units. So our question requests us to calculate the distance CD. We want to calculate this distance here. We want to calculate.
Yeah.
What are we given? We're given OB, which is 13 here. We are also given AB, which is distance from here to there, which is 24. So by now, I believe you remember the midpoint theorem, which talks about this distance here. The distance AD is equal to the distance DB. So in order for us to find the distance DB, what can we do if we are given the distance AB?
It's gonna be AD equal to DB.
Yes, AD, it will be equal to DB, right? That is very true. So that gives us AB, but AB in this case is given. So if AB is given, how can we find one of this side is given as 24? We know these two distances are equal. These two distances are equal. So if these two distances are equal and we're given the distance AB, how can we find the distance DB?
By doing OB, by using OB.
Yes, and then the other thing can be to divide. You divide this AB by 2 because it is a midpoint. So you divide 24 by 2. You're going to get this side DB as 12. Is that clear?
Yes.
Yeah, because this distance is the same as that distance. Therefore, you can just divide by 2 so that this side shares its 12 from 24 and this side shares its 12 from 24. Therefore, it will be 12 here and 12 there. But we're looking for that 12 we have there. Are they that clear to you as well?
Yes.
All right. Can you predict what's going to be the next task after having these two sides? What next are we going to do? Yes, we're going to find this side, right?
Yes.
What are we going to use to find this side?
Theorem of Pythagoras.
We use theorem of Pythagoras. Can you construct
No.
theorem of Pythagoras from this information we're given here? Let's construct the Pythagoras. Not using X, not using Y, not using R. Let's use this ODB. Can you construct for me?
OD squared.
So it's OD squared
equal to open brackets 13 close brackets squared.
It's OD squared plus DB, right?
Yes.
And then equal to what?
Equal to OB.
You all see that, right? And now
Yes.
we're going to have OD squared plus DB, in this case is 12. Therefore, it's going to be 12 squared equal to OB, it will be 13. So it's
13 squared.
Yeah, definitely. So you take this to the other side. What are we going to have when we take that to the other side? We're going to have OD, which is equal to 13 squared minus 12 squared. Can you use your calculator to tell me what do we get when we add 13 squared minus 12 squared, which I think is the same as 169 minus 144, but you can just verify that for me.
Oh, yeah, that's true. That's true.
So what is this equal to?
Equals to square root 25. Cool. Equals to 25.
Is equal
to 25.
So in order to make OD the subject of the formula, what do we do?
Well, we put a square root.
Both sides,
Use a
right?
square root. Yes.
So that we have positive, negative, but in this case, we are focusing on the positive answer only. So it's going to be a root of 25, of which is a 5. You see?
5. Yes.
So we now have this side. The side OD is equal to what? Is equal to 5, right?
Yeah. I don't find a CD ne. Find a CD.
Okay, A, because that is our main question. Our main question is for finding this side CD.
Okay.
How can we find CD?
We can use OB.
We can use OB, definitely, because we know OB is equal to what?
OB is equal to OD.
OD plus what?
Plus
Plus DC, right? OB is equal to OD plus DC. Do you see that?
Yes, sir.
And now let's substitute. Where we have OB, we substitute 13 equal to where we have OD, we substitute 5. And then we add with DC. So then let's make DC the sum of the formula. So when we make DC the sum of the formula, what are we going to have? We're going to have 13 minus 5, which is what? Which is 8.
Is 8. 8.
Did you get the same answer?
Don't I your name crossed?
Yeah. So this is how you attend to this question. Now,
One era rater.
yeah?
One era rater.
One error to it. Not that she. Okay. Let's also do question number 1. So we are given, on this question, we're given that OR is equal to 6 units. And PQ is equal to 16 units. Our task is to find OQ. We want to calculate OQ. OQ is not given in this case. So the question is, how do we calculate OQ? Again, we take advantage of the information that is given here. If PQ is equal to 16, what will be the value for RQ? If PQ is equal to 16, what will be the value of RQ?
8.
8, definitely. You just divide this by 2, you will get that. Because this distance here is the same with that. By midpoint theorem. Midpoint theorem applies only when we're given 90 degrees. And that is what we're looking for. And after having that, we can calculate OQ. What are we going to use to calculate OQ?
Pythagoras.
Pythagoras. So it means here we're going to have OR squared plus RQ squared, which would be equal to OQ. Do you agree with me on that one?
Yes.
So this theorem here, you are allowed to write it as OQ squared, which is equal to OR squared plus RQ. So you haven't violated any rule by doing so. So you just write it in another way, and then you will have what is needed. So that is clear, right?
Yes.
Then from there, we substitute. So we're going to have OQ squared, which is equal to OR is given as 6 units there. And then QR, we got it as 8. So it's 8 squared. So therefore, we're going to have OQ, which is equal to 6 squared is 36. And then 8 squared is 64.
64.
What do you get when we add these two?
100.
We still have a square then. We get 100. To make OQ the same of the formula, we have to root both sides. So it means we're going to have root,
Yeah.
which is what?
Which is 10.
And that's it. This is how you're supposed to calculate OQ from the first question. I believe we're together on that one. Is that so?
Yes.
Are the
Yeah.
And is it pure? Okay, you can send to me before we proceed. I will want to which ones are difficult for you.
Okay.
Okay, I know. Don't worry much about those ones. Is it the proof of the theorem?
Yeah, the theorem true way.
Yeah, I think this got the theorem are to cover. In my theorem, and question number 2. The angle at the center is twice the angle at the circumference. So I'm going to do the proof with you for that theorem first before we cover the question. So it means after the proof, we'll then do your questions, if time allows. But if time doesn't allow, we're going to attend to your questions next week, Thursday. Is that okay?
Yes, sir.
Yeah, but if you are very keen of wanting to get the solutions for this, I can give you. So I can give you the solutions, but let's do step by step so that it does not confuse you, because this is a difficult chapter. So we don't need to rush, because otherwise if we rush, you won't get a thing. So let's do it step by step. Up to so far, I've covered the second theorem. Let me cover the third theorem. The proofs of these theorems, they are very important. You must know how to prove. I proved the 2 theorems with you. I believe you remember how we proved the midpoint, and then you remember how we proved the tan chord. Today, I'm going to prove the third theorem, which says the angle at the center is twice the angle at the circumference. So I'm going to give you that proof just now. You must not forget it. Are we together?
Yes.
Adi, are we together?
Yes.
All right. Let me give you a very important proof. Not forget. Don't worry much about those questions. I will attempt you with this theorem. So now, so this is the theorem we're going to prove, which say that the angle down here is the same as the angle up there. It's what we are going to prove together. Let me check if we have 6 minutes. So hopefully I'll be able to cover this in 6 minutes time. So this is what you do in order to prove this theorem. So you need to construct a line between these two. From the center, you go and join a line that goes straight to that point there. So, and then after joining by these dotted lines here, so there's something which you must be able to observe, that the radius here is the same as the radius there, because both of these are the radiuses. Do you all see that?
Yes.
Yes. So let's say there is A, there is B, and there is C. So these are radiuses. And once they are radius, it means this is an isosceles triangle. And if it is isosceles triangle, the angle here is the same as the angle there. Let's name this angle X. So once those are angles X, then we go to this other side, wherein if there is R again here, we have what? We have R, which means these angles here, they're going to be equal as well. Let's say these are angle 1, and up there is also what? It's also angle 1. So and then from there, this is O. The center is O there, where in this we can say is O1, that is O2, and there it's O3. So let's obtain all these O's here. We start with O1, and then we go to, let me say this is O2, and then that is O3. We're going to obtain these 3 O's. We start with O1. How can we obtain O1 there? We're going to say angle O1 plus X plus X. Angle O1 plus X is equal to what? If you remember, it's equal to 180 degrees.
180.
Y is equal to 180. Angles in what? In a triangle. Do you see that? So now we make O1 the side of the formula. So it means we're going to have 180. This we take to the side, we're going to have minus 2x like that. So that's the first one. We go to O2. O2, we're going to have O2 plus y, which will be equal to 180. And the reason is the same. These are the angles on a what? On a triangle. So then it means we're going to have O2, which is equal to 180 degrees minus 2y. Are we together up to there?
No, can I repeat it? Angle O2.
Angle O2 plus y is equal to 180, because these are the angles in a triangle AOC.
Okay.
Then now from there, we're going to take advantage of angles at the center. If we add angle O1 plus O2 plus angle O3, it's equal to what? It's equal
to 360.
Y is equal to 360. So these are angles in a revolution, right?
Yes.
But angle O1 and angle O2, we already have them. We know these angles. So angle O1 is 180 degrees minus 2x, and angle O2 is 180 degrees minus 2x, 2y, and then plus O3, which is equal to 360 degrees. I hope we're together. Oh, yes, that's correct. And from there, we add this with that. When we add these two, what are we going to get? We're going to get 360 degrees minus 2x minus 2y, and then plus O3, which is equal to 360 degrees. Are we still together?
Yes.
Then we take all this to the other side. So it means we're going to have O3, angle O3, which is equal to, when you take this 360 to the side, it's going to be 360 minus 360, which is 0. And then we take this to the side, it's going to be positive 2x plus 2y, like that. Which means O3 is 2 into, we take 2 as the common factor, we have 2 into x plus y. So that is your O3. But now, let's recall angle A up there. Angle A is the same as x plus y. So you can just add. Okay. So angle A is equal to x plus y. So this angle up here is x plus y. But now we just found that angle O3 is equal to 2 into x plus y. What does that tell you? What does that tell you?
Equal angles.
So angle at the center is twice the angle at the what? At the circumference. Do you see that?
Yes.
That's all. That's what we wanted to prove. Ask me any question before we wrap up for the day. I think I can't have questions for these. So, but next week I'll make sure we then do as many questions as possible for this theorem together with another theorem. So for now, the main task was to do this proof. If you did not understand the proof, it's your turn now to ask me where you did not understand so that I assist you before we wrap up for the day.
Ngapha 180 minus 2x.
On this one.
Plus, yeah.
This one.
Yeah.
All right. O1. If another 180 minus 2x, Rojuana have a equation. So O1 is equal